So for this next question, we're told that if sine theta is equals to 3 over 5, you have to find tan theta. So let's draw a right angle triangle like this. Okay, draw a right angle triangle. Then the first thing to do is to just check, put the angle in any part here. This right angle triangle. So sine is so, opposite over hypotenuse. So that's 3 over 5. Opposite is 3, hypotenuse is 5. So this place will be 3, hypotenuse will be 5. So you just need to find this particular part here. This part here, x. So this part from Pythagoras theorem is supposed to be 4. Because you have 5 times 5, that's 25. 25 minus 3 times 3, that's 9. 25 minus 9 will give you 16. Then square root of 16 is 4. So this place is actually 4. You have to find tan theta. So tan is 2. Opposite over adjacent. So opposite is 3. Adjacent is 4. So the final answer is just 3 over 4. So that's option A. So for number 29, you have to find the gradient of a line which is perpendicular to the line with this equation. So this is how you're going to solve it. So to solve this question, you have to find the gradient of a second line. So the first thing is the line that you are given, or the equation you are given. So try to make y the subject of the formula. So if you do this, you're going to get 2y is equals to minus 1 minus 3x. Then divide all through by 2. Because I want to make y the subject. So that will give me y minus 1 over 2 minus 3 over 2x. So y is now the subject of the formula. So the number in front of x like this, the coefficient of x will give you the gradient of this line. So the gradient of this line is y equals to minus 3 over 2. That's like comparing it to y is equals to mx plus c. The number in front of x is the gradient. That's the coefficient of x. So using that same idea, you can find the gradient of the second one. So if two lines are perpendicular like this, they obey this equation, m1, m2 is equals to minus 1. So the first gradient that we have is minus 3 over 2. So that will be minus 3 over 2, that's m1. So we're just looking for m2. So put your m2 here. This will be minus 1. So to find m2, just cross multiply. Okay, cross multiply like that. So this one will give you minus 3 m2 is equals to minus 2. So minus cancel minus. You're going to have 3 m2 is equals to 2. Then how can you find m2 from here? Just divide both sides. So m2 will just be 2 over 3. So the gradient of that second line is 2 over 3. So check it in the option there. 2 over 3. So that's option 1. Alright. So for this next question, we're told that the locus of a point equidistant from 2 points P, Q is a perpendicular bisector of PR passing through. So what I'm telling you to do is, you have 2 points P and Q. So you have P like this, you have Q like this. So there is a line passing through their middle like this. The line is bisecting them to 2 equal parts. They are telling you that which part will this line pass through, which coordinate will it pass through. So that line will pass through the middle of P and Q. So to find the middle of P and Q, all you have to do is just use the formula that will help you to find that. That's the midpoint formula. So just check the first value of x here. The first value of x, as you can see here, is 6. That's x1. The second value of x is 4. So add it together and divide by 2. So 6 plus 4, divide that by 2. The second value for y is, the first one is 2. The second one is 2. So you're going to add that together. 2 plus 2 and divide it by 2. So 6 plus 4 is 10. 10 divided by 2 will give you 5. So this one will give you 5. 2 plus 2 is 4. 4 divided by 2 will give you 2. So 5, 2. That will be the middle of P and Q. So that's option B. Be careful of option A. They're trying to confuse you. A is not the answer. The answer is option B. The next one is to find the angle subtended at the center of a circle by a chord which is equal in length to the radius of the circle. So if you follow this question very well, you see that the length of the chord, okay, is equal to the length of the radius of the circle. If you have a circle like this, and this is the chord here, this is the center of the circle, and this is the radius. From this question, the radius is r. The chord is also r because the chord and the radius have the same length. If you look at this kind of triangle is called an equilateral triangle. And the angles in an equilateral triangle is always 60. All the angles here are 60. This is 60, this is 60, this is 60. So this is the center of the circle. So this chord here will form an angle at the center of the circle of 60 degrees. This angle here will be 60. Okay, so the answer is just 60 degrees straight up. So for the next one, find the capacity in liters of a cylindrical well of radius 1 meter and depth of 14 meters. So look at how you're going to solve it. It's very simple. Capacity means volume, and this is a cylinder. What is the volume of a cylinder? That is pi r squared h. That is V is equals to pi r squared h. So just plug that into your formula. Your pi is 22 over 7. So you have 22 over 7 times your radius is 1, as you can see from the question, and your depth, the height, is 14. So you are doing 1 squared. So 1 squared is still 1. So all you have to do is just do cut here, 7 here 1, 7 here 2. So at the end of the day, 22 times 1 times 2, that will give you 44. So the volume is 44 meter cube. So the next step is just to convert this answer to liters, because you have to put the answer in liters, as you can see here. Find the capacity in liters. So the next step, just multiply this answer by 1000 and you get your final answer, because 1 meter cube is equals to 1000 liters. So what will be 44 meter cube? Just multiply this answer by 1000. So the final answer will be 44,000 liters, which is option A. So for the next question, to find the area of the figure above. So this figure has two parts. So you have a semicircular part like this, then you have a rectangular part like this. So you have to find the area of the whole shape. Now if you want to find something like this, you need to break it down to two parts. So the area of this part is A and the area of this part is B. So the diameter here is 5, as you can see. So you need to find the radius. That will be divided by 2. Okay, so to find the area of that semicircular part, you just do something like this. So you have area in B pi r squared, but you have to divide it by 2 because it is half of a circle. So that will be 22 over 7. So the radius is 2.5 because you have diameter as 5. So you square this and divide it by 2. So if you work all these calculations out, you will get 9.82. Okay, that's the area of the semicircular part. Then the next part is to get the area of the rectangular part. So if you check that, you see from here that the rectangular part has a length of 15 and the width is 5. So length times breadth will give you 15 times 5, which is 75. So the area of the rectangular part is 75. So the whole area of the whole shape is you just add them together. So you just add 75 to this guy. So this one will be plus 75. That will be the area of A and B. So plus 75 to this, 84.82. So that will be the area of the whole shape altogether. So that will be 84.8, which is the final answer. For number 21, you are told that a binary operation on the real set of numbers excluding 1 is such that m n member of real numbers. Then they gave you this operator sign here. Then this equation. Find the identity element of the operation. First of all, you need to write the relationship first. So you have m operator n. That's the meaning of that sign. You have m plus n plus mn. So once you have it like this, it's very straightforward. You have to find the identity element. Identity element just means that something they are going to use to multiply something that will give you that same thing. Take for example, 1 times 5 is 5. That means the identity element there is 1, because 1 times 5 will give you that same thing, which is 5. Assume that the identity element is n. So you're going to do m operator n. But the answer that you must get must be m, because I'm assuming that the identity element is n. So you just come here and substitute into this guy here. Substitute into this guy. So you're going to get m. This is the first one, m. Leave it as m. Then you have plus n, which is your identity element, plus mn. But the answer that you must get must be m. So all you have to do is just simplify this. So you have m on this side, this m on this side, we cancel this m on this side because they are the same. So you have n plus mn. Everything equals to 0. So you just factorize this part. If you factorize this part, you can see that n is common, which is the identity element. Is common. That will be n into 1 plus m is equals to 0. So if you finish this up, divide both sides by 1 plus m,